Hi students, welcome back. Coming to our next topic, that is the performance analysis. So we have to check the performance of an algorithm. So the algorithm performance can be analyzed by using two techniques. Okay, so with the help of two measurements we can analyze the algorithm. So that one is the space complexity and time complexity. So by using the space complexity and time complexity, we can analyze the algorithm performance. Okay, the space complexity indicates means actually the performance analysis is an algorithm. An algorithm is said to be an efficient. An algorithm is said to be efficient. When you say it is efficient and fast, when an algorithm is said to be efficient and fast, if it takes less time to execute, okay, whenever the algorithm takes less time to execute and consumes less memory space. Okay, so with the help of these 2 points, okay, the algorithm is said to be efficient and fast if it takes less time to execute and it consumes less memory space. Then we can say our algorithm is fit, okay, and the performance is very good. So the performance analysis can be measured in the terms of space complexity and time complexity of an algorithm. So the space complexity is nothing but is the amount of memory space it is used. It is measuring the amount of memory space required by an algorithm during course of execution. Okay, required by an algorithm during course of execution. Okay, so the space complexity is nothing but the amount of memory space. So the algorithm that uses that amount of memory space required by an algorithm during the course of execution. To execute one particular algorithm, the space complexity calculates the amount of memory that is used to execute the algorithm. Whereas coming to the time complexity, so here the time complexity is in how much time it consumes to execute the program. Okay, how much time it consumes to execute the program. Okay, so with the help of these two techniques, the space complexity and the time complexity, the performance can be analyzed in the algorithm. So let us see one by one. So first is the space complexity. Space complexity. So I said the space complexity is nothing but the amount of memory space required. Amount of memory space required to execute an algorithm. Okay, so that you call it as a space complexity. So this actually an algorithm generally required the space for what? So why the algorithm required space? Okay, so the algorithm generally required space for instruction. You call it as an instruction space, data space, and environment space. Environment space. Okay, for this three reasons the algorithm generally required space. So the algorithm is checking the space in terms of instruction space. How many instructions it is taking, means it's a space required to store executable version of a program. So all the instruction consisting of some executable program. So how much space is required for that executable program? Okay, that you call it as an instruction space. Actually the space is fixed but varies depending upon the number of lines of code in the program. So it depends upon the number of lines that are taken to execute the program, that you call it as an instruction space. Now coming to the data space. Data space is nothing but it's a space required to store all the constants and variable values. So to store the constant and variable values, we will use the data space. Okay, so how many variables we are using, how many constants we are using, that calculates the space, means how much space it is consuming. Okay, so that is a data space. Now coming to the environment space. So environment space is nothing but it is required to store the environment information needed to resume the suspended function. Okay, so whatever the suspended functions that will be there, so that will be resumed in the environment space. So the space complexity generally requires these three terms: the instruction space, data space, environment space. Okay, so now let us see, there are two different types of space complexity. The space complexity can be calculated in two ways, means based on the program. The program may be the constant program or it may be a linear program. Okay, so the first one is the constant space complexity. Okay, and the next one is the linear space complexity. Okay, the space complexity will be used to calculate, means how much memory it is using, the algorithm is using in the system. Okay, so that space complexity will be divided into two: constant space complexity, linear space complexity. So let us see what is a constant space complexity. Suppose it is a simple program, it is a constant steps, means a fixed steps will be there. So constant space complexity, suppose int square, the variables or data items are int a. So return a star a into a, and so this is a simple program. It is it occupies only the constant space complexity. Only one variable we are using, only that variable is having some constant value, the size. Okay, the data type, based on the data type the size may be measured. Okay, here we are using the integer. So this integer is having some constant space complexity. Only one integer we are using, one integer value, the same integer value here we are using. Okay, so here algorithm requires fixed amount of space. Only it is using fixed amount of space. Only one variable we are using, that is only the fixed amount of space for all the inputs. How many inputs here? Only one input is there. Okay, so for that all input values we are using the fixed amount of space. So this type of complexity you call it as, so this space complexity is constant. So the main thing here you have to note that why we call it as a constant, because we are using the fixed amount of space for all input values. So for that reason we are saying this type of programs or the algorithms is a constant space complexity. Okay, the memory that is used will be the constant. Now coming to the linear space complexity. What do you call this linear space complexity? So here the name indicating that the space will be varying. Let us take the example. So before going to know the example, let us see some of the instructions that you have to follow while you are calculating the linear space complexity for an algorithm. Okay, so the instructions that you have to follow, the formulas that you have to follow for the linear space complexity is the space needed for an algorithm can be calculated. The space needed for algorithm is based on, suppose the size of variable, suppose size of variable is n, means you take it as a one word. Okay, and suppose if your array of a values you are using, if you are using array of a values, so it takes the n word. Okay, if you are using only one, means size of the variable, so whatever the size you are taking, so here I am taking any variable, so that single variable is having one word. If you take two variables, it takes the one word each. Okay, array of a values, you take it as a n words. Next, if you are having the loop variable, suppose the loop variable I, the space complexity, the memory that used to store that loop variable is one word. Sum variable, if you are having any variable with sum, okay, the sum variable occupies one word space complex, so space. Okay, so these are the standard for the variables. The size that occupies in the memory is the one word, n word, okay, based on the instruction. So let us take one example for this linear space. Int sum of int array of and int n. So here we have taken two variables, one is the array and another is an integer variable. Int sum is equal to 0 comma I. Okay, we have taken two variables, sum is equal to 0 and I. So here I am using the loop for I is equal to 0, I less than n, I plus plus. Okay, sum is equal to sum plus a of I. Return sum. So this is an algorithm. Okay, so this is a program represent an algorithm. Here the amount of space required by an algorithm increases with an increase in input values. So we call it as a linear space. Why we are calling this as a linear space? Because here the amount of space will be increased in the memory. Here we are using so many variables like sum, I, n. Okay, so for each variables the input values are increasing, means automatically the space complexity is also increasing, means it is linear. It is not constant. Okay, so in this example, what is the space complexity? Space complexity, linear space complexity will be linear space complexity. Let us see. So here we had for these only for comments and these braces, only the space complexity will be only 0. Okay, so first here it is taking int sum is equal to 0 and the space needed for the size variable n. Okay, the space needed for the size variable n is one word. Okay, and the array here we are using, okay, the array of a values that you have to take n words. Okay, and here I have taken the loop Okay, the loop here I had taken. So for that loop it is taking, for this loop it is taking one word. Okay, and the sum of variables, here the sum of the variables, it is occupying one word. So total space complexity is n plus 3 words it is using. Okay, the size of the variables of for n is one word. Okay, it is means only the variables here we are taking. So how much amount of space that is occupying in the memory, that we are calculating here. The space complexity, the size of variable n is one word, because it is only one variable, one word. And here we have taken the array. So array means a group of variables waiting. So n words. And the loop for calculating I, for every time it is taking one word. So that is one word. And the sum of the variables, for sum we have taken one. The space that is occupying in the memory, some variable is occupying one word. So total the space complexity for this example is n plus 3 words. Okay, so this is the how to calculate the space complexity. So for each variable you are assigning some amount of space. So that is the space complexity. This is how you have to calculate the space complexity. The space complexities will be two types, constant space and the linear space. Okay, so the constant space is having, it requires only the fixed amount of space for all the input values, whereas in the linear space, when the input values will be increasing, automatically the algorithm requires more space. So that you call it as a linear space complexity. Thank you.